It's not that some of the methods that we were using weren't working, but like a table of values always works. But it's gonna take you some time to sit there and like plug in the values for each of these graphs, right? You're not even necessarily, I mean, you could draw, once you get a couple points, I think it'd probably be okay, but I don't know, that's not the fastest way, right? So what I showed you, especially if you're going to label all pertinent information, so in particular like slope and y-intercept, if you're going to identify all that information anyway, why wouldn't you just use it to produce the graph? Remember, you only need 2 points to really get the for a line, okay? Remember, pertinent information also includes x and y on your grid, okay? And then from here, I'll just do the first equation here, the black one, okay? So right off the bat, I know my slope is going to be, we know slope is rise over run. And so it's 3 over 2. So if I were to put that into words, it would be up 3, right 2. Okay, there's your slope. Now your next question should be like, where am I going to start from? Well, I'm going to start from the other number that's sitting there. My y-intercept. My y-intercept is at the point 0, -4. Okay, and that's about all you could do with this now. So you just say, okay, I'm going to go find 0, -4. That'll be here. And then I'm going to, the slope is like how we move around. So it's like, okay, I got my starting value. How do I move? Well, I'm going to go up 3, 1, 2, 3, right 2, 1, 2. Put a point there. This is way faster than doing the tables of values, right, for both of them. Okay, so I do it again. 1, 2, 3, 1, 2. There's another one. 1, 2, 3, 1, 2. You get the idea, okay? Now the opposite, you can also go the opposite direction, right? We could go, the opposite of going up 3, right 2 would be to go down 3, left 2. Okay, so I can go to my starting value again. And I go down 1, 2, 3, 1, 2. Right, and I know that's true because if I were to, like, you plotted all these points here, I went up and right, up and right, up and right. The opposite of going up and right would be to go, you could start here and go down left, down left, down left, down left, down left. Okay, so there are your points for that black line. Okay, so I'm going to draw them. And remember the line, it's not a line segment, it's a line. Okay, so it doesn't just end, you have to have your arrowheads on there too, because I could keep plugging in values of x all the way till whatever, right? And then you're good. All right, does anybody have any questions with that one? I think that was the harder of the two. Okay, it wasn't as hard as the first formative, but it still had a little fraction in there. Be careful with the fractions, okay? So for the blue graph, you're going to have a slope. Again, is rise over run. I always like writing this because it helps me, right? The rise, remember, you can always write anything you want divided by 1. Whatever you want, okay? Because it hasn't changed anything. So the rise is going to be -2, and the run is going to be 1. Okay, so that means in words, we're going to go down 2, right 1. Okay? But you got to ask yourself, okay, well, that's all fine and dandy, but where do I start? Right? Well, we start at +10, the y-intercept. Right? 0, 10. Okay, so you go up, find 0, 10. Okay, and then you're just going to go, okay, down 2, right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. Oh, look at that. They crossed. Okay, that's enough. So you can connect them. Okay, put your arrowheads on. I suppose we should also label our graphs, even though I use the colors. Okay, this would be like a full mark question, I would say, unless anybody notices anything else I'm missing. Okay. Oh, the point of intersection, where the two graphs cross, that's what the point of intersection means. Well, it looks like they cross right here. Right? That's going to be your point of intersection. Okay, so we're going to get, the point is going to be, okay. Does anybody have any questions to that? It's not going away, okay? So you're going to have to do that. And I don't think using the table of values is the best way to do it. Okay, you're going to run out of time. You're not going to get everything, or at the very least, you're going to spend too much time on something that could be done very quickly and not be able to spend enough time on the questions that require a little bit more time, okay, like the solving ones. Okay, so when we show you things, we're trying to show you probably the fastest way to do it. It's the same thing as when we were looking at solving questions today. You can solve like by inspection all day long, right? You could get, like, an inspection means like guess and check, right? That's always a method. But if one of you sits and does guess and check and somebody else actually follows the process we showed you today, it might take you half the time to follow the process. There might be instances where it's faster to guess and check, sure, but for the most part, it's probably faster just to use the process that we showed you. Okay, guess and check. You can see how ugly I can make it as ugly as I want. Okay, and sometimes if I make those questions, I'm going to make it ugly from the mindset of like, I don't want you guessing and checking. Okay, so when we show you stuff, it's a process to make your life easier. Okay, so that's the way I wouldn't mind seeing that question done. Can I mark it wrong if you use the table values? No, unless I explicitly say graph using y equals mx plus b, like the method, then I could mark it wrong. Or if I say use graph using the table values method, whatever, okay? If I'm specific in my question, you have to do it that way, right? All right, we'll go down here and expand and simplify each of the following, okay? So you can use algebra tiles. I don't know if in any particular algebra tile set there's enough to actually get you to do this without running out, but nonetheless. Okay, all it means, this first line we talked about how to get, like, your first move should be to try and get rid of the brackets, right? And so I'm gonna like expand, that's what this means, the rainbow kind of piece, or distribute, that means expand, which basically means get rid of brackets. That's what that means to me. Okay, and then fully simplify means collect like terms. Okay, just so you guys know what I'm asking you when I put these sort of words on the test, right? So we're gonna expand some stuff out, and then we're gonna clean it all up and organize by collecting like terms. Okay, and that's the gist of it. All right. We'll need to already set the copy if you're copying. Okay. So 6 times 2 with an x on it. 6 times 2 is 12 with an x on it. That's 12x. That takes care of the first one. Right? That's this right here. Okay, that's your 12x. And then you got plus 3x. Okay, I didn't need to do anything there. Now careful with this one. I'm sure somebody made a mistake with this. We're taking all of the minus 5 and putting it into with the 2x. Okay, so we're going to get minus 10x. And then the plus 15 is just floating. Okay. Okay. Now it looks like right here, if I were to like identify like terms, it looks like those 3 things are like terms because they all have an x on them. They're not x squareds. They're also not just numbers. They're just x's. So there's those algebra tile rods. And so if they're all the same thing, I can add and subtract them together. That's what we mean by collecting like terms, right? So you can go 12 take away 10 plus 3, or 12 plus 3 take away 10. Doesn't matter the order, right? So you go 12 plus 3 is going to be 15. And then take away 10. that's going to turn into 5x plus 15. Okay? Any questions? Next one's a little trickier just because there's more stuff going on, but same principle, okay? Trying to get rid of the brackets and then clean up whatever mess is sitting there by organizing like terms. That's all it is, okay? So 5x times an x is 5x squared. 5x times 3 is plus 15x. That takes care of the first one, the first little rainbow bit. Then the next one's negative x times 2x and times negative 5. That's going to be minus 2x plus 10. Two negatives make a positive. Okay, and then the last one is just distribute that negative into the bracket. Get minus 7x squared. Okay, and now you can clean it all up by identifying like terms. So we got some squared terms. We've got some rods, and we got the individual numbers. So you rewrite this and then clean it up. Okay, 5x squared minus 7x squared plus 15x minus 2x plus 10. Okay, that's everything organized now. Okay, I got all my squares, circles, and then the little underlines all together, and I can just do the math. 5 take away 7 will be negative 2 with an x squared on it. 15 take away 2 with an x on it would be plus 13x plus 10. Okay, that should be your final answer. Whoa, did I miss something? Yeah. I'm just looking at it now. It is negative 2x squared. I just caught that. Got distracted switching between colors, I think. And then it's not 10. Well, I made a mess of this question. Holy jeez. All right, hold on. Give me a sec. Go back. They be stressing out? Think they did it wrong? Here, I gotta fix the middle ones. One sec. Okay, are we happier? Nobody said anything. Okay, now we can reorganize, sorry. Okay, 5x take away 2x squared plus 15x minus 5x minus 7x squared. I did this question earlier that felt wrong when I looked at it. I was like, that doesn't look familiar. When I'm looking for the error. Is it minus 5x though? Did I make another one? Opal?
Shouldn't you put 7x squared with the other x squared?
Yeah. I'm gonna do that. I'll do that in a sec. I'll reorganize. Yeah. Is there something wrong here? Let's pay attention to this because I know this is a contentious. I'm not gonna say I did this on purpose, but I caught it nonetheless. Amanda?
Would it be positive?
It's the negative x times the negative 5 turns into a positive 5x. Okay? Okay, just be careful. This is why I don't know, it is easy to make a sign error or just something completely random like what I did. Okay? I got distracted switching between the colors. I wasn't paying attention to what I was doing. Okay? So let's organize and then that should be it. Okay. And you don't have to show this many steps if you don't need to either. I'm just for everybody's benefit so that there's no questions on where anything comes from. Like I'm just writing steps. Okay. So everybody knows exactly every line, where everything came from. Okay. So now these are all x squared, x squared, x squared. So I can add and subtract those together. And then I've got the x and the x's together, okay? So I just do the math. 5 take away 2 take away 7 should be negative 4x squared, if I'm not mistaken, plus 15x plus 5x. Yep, 20x. That looks better, I think. Questions, comments, concerns? Okay. All right. I'll post this too in case if you want to watch it again, okay? Okay, I'll post it later. All right, solve for x in each of the following. Okay. So this is what I was saying. These are like simple, one step and two step. These aren't the complicated ones that we did, the multi-step ones, right? They're a little harder. Okay, but for these ones, this is addition on the left, and so we can create what we call the zero pair. We can subtract 15, So x should equal what? 26 minus 15, what is that? Are we happy? Yeah? Okay, so there's our answer. Now let's give it a little check, okay? And I showed you this before, right? I want to check the left side versus the right side. So the left side says x plus 15 has to equal 26. So let's check to see if that's true by taking what I found my answer to be and plugging it in for x. And we're going to see if we're right or wrong. So I'm going to take 11 for x and I'm going to plug it in, or what we call substitute. That's another word, okay? I'm going to substitute the fact that x equals 11 in for x. I get 11 plus 15 equals 26. Does 11 plus 15 equal 26? Well, yes, it does. Oops. So we're right. Okay, left side equals right side. We're good. Okay. That one's a little trickier. Like, I think some of the more complicated examples are actually easier to see the left side equals right side check. Okay. Now, as easy as I thought the one steps were going to be, I did make this one up, and I thought, oh, that's kind of a nifty little trick there. Okay, it looks like a one step, but it's not really a one step, is it? It's a little trickier. And it's a little trickier because I've got this minus x there. Okay, because remember, I could choose to write this like this. Right? And if I move the 4 over, is the x technically by itself? No, there's still a negative 1 on it. Okay, so you can do this one of two ways. You could run with this question like this. You could take away 4 from both sides. And you get negative x is equal to 8. But x isn't by itself. It's got a 1 on it. So to get rid of that, you could go, okay, I'm going to divide by negative 1. X equals negative 8. Okay? That's one way to do this question. Or you could do two flops around, right? You could say, okay, well, 4 minus x equals 12. And I'm going to add an x to both sides. And I'm going to get 4 equals 12 plus x. Is x by itself yet? No, we're still stuck with the 12, right? So then I can go, okay, well, I'm going to take 12 away. Okay? And so then you'll get x is equal to 4, take away 12. X is equal to negative 8. Okay? Because I did this two different ways, and I got the same answer, I'm not going to check this one, okay? But we got the same answer, so we know we're good. All right? I just want to get it done before you guys leave. All right. Okay, so we come down here. This is a little bit tougher, but still not on the multi-steps yet, I don't think. Okay, this is still two-step. This is actually from the very first lesson on the algebra tiles, this question. So here's what I'm going to do. I'm going to get all the x's on the left, and I'm going to get the numbers on the right just by moving stuff around, okay? So I'm going to add 2x here because it's subtract on the right. Add 2x, add 2x. And then I'm going to take away 6 from both sides. Okay? So I'm going to get 4x plus 2x is equal to negative 6. Take away 6 more. And now I have all my x's on the left and my numbers on the right. And I can just clean it up. I'm going to get 6x is equal to negative 12. Divide by 6, divide by 6. X will equal negative 2. Do you want me to check that, or you want me to do the last question before you guys leave? Still got 2 minutes here. Okay. Okay. So I'll check this one too, just before you leave, all right? So, one of two things here. You can divide right off the bat by 3. That's allowed, because 15 is divisible by 3. Or you can go like this and distribute it in. And you're going to get 3 times 2 is 6x. Take away 3 is equal to 15. 6x, if you add 3 to both sides, is going to equal, there's a 0 pair there, you're going to equal 18. Divide both sides by 6. X equals 3. All right? I do want you to check that stuff, but for the interest of time, you guys are leaving. That's it, okay?